It is highly recommended you start off by cleaning the grooves of the inside upper end of the suspension arms. The manufacturer used a lot of red Loctite, and some of it spilled and hardened inside these grooves. I am using a small precision file to do this job, but you could just as easily use a popsicle stick and some medium grit sandpaper. Also, don't forget to clean up the mounting block on the scooter as well. Doing this will increase the chance of a snug and smooth fitment of the arms. Next, assemble the two upper suspension arms together using the lower connecting aluminum rod. Using a rubber mallet, strike the arms until they are fully pressed together. Don't use a steel hammer, as that could chip off paint. If the threads of your aluminum rod wasn't damaged, then you can skip this step. However, you might find yourself having to rethread the rod if you banged on the ends with a pin punch too hard to get it out. Use a thread size identifier plate to ID the tap size. It turned out to be a 6mm x 1. Once ID'd, apply a small amount of cutting fluid, then tap away. Finally, secure the two upper suspension arms together with 6mm screws. It's always a good idea to clean up the mounting block one last time before locating the upper suspension arms and securing them in place. I decided to use a Dyson portable vacuum cleaner to reduce as much dust and debris as possible. Once the upper suspension arms are located in place, secure quantity 3 8mm hex head screws on the left side and quantity 3 8mm screws on the right side manually. You should only be able to thread them in slightly, as a large amount of resistance will be encountered. Shift the arms slightly if you need to align the screwing holes. Before screwing in all the way, ensure Loctite is applied. The red kind is overkill, as there is already so much resistance even at this beginning juncture, so I am using blue here. You could do all the screwing with a ratchet wrench, but utilizing an impact driver is much more efficient, especially since you have a total of 6 screws to torque and tighten. I forgot to mention earlier, but ensure there are locking washers installed in the screw stack-ups. This increases the resistance to loosening. This is probably the last component you want to fail when riding at over 40 miles per hour, so do a final torquing with a small ratchet wrench. If I had to guess, about 5 foot-pounds of torque. You want a delicate balance between securement and stripping the threads off. Secure the pump female valve end to the shock absorber male valve. I weigh about 160 pounds, or about 70 kilograms for those of you in the metric parts of the world, so I prefer a little bit over 100 psi. If you weigh more or less, please adjust psi accordingly. Next, install the lower swing arm assembly consisting of the pivot shaft, which reduces the upper and lower suspension arms to 1 degree of freedom. Then install the swing arm securement rod, which locks the swing arms to each other, and finally install the lower shock absorber shaft, which secures the air shock absorber to the swing arm assembly. During the course of installing the upper shock absorber shaft, I discovered that the canister top shaft opening is a little too small, and I needed to take off a fraction of a millimeter in diameter on the shock absorber upper shaft. There are a number of ways to shave off a couple of micrometers. You could use a lathe, a mini lathe, a drill press, or pretty much any piece of machinery that can secure a round workpiece in place and rotate it. I find a portable power drill does the job most effectively and easily. I would recommend a coarse grit sandpaper. Here I am using 80 grit, since the steel rod is really hard and resistant to material removal. I would say about 5 seconds of sanding at a time on full speed. If it is still too large, then repeat. You certainly don't want to oversand, as that will be more difficult to mend. I also found it difficult to get the upper shock absorber shaft rod to fit through the second aluminum spacer. So here I am sanding the opening to create something similar to a countersink. This is done with a standard Dremel tool with a circular sanding head attachment. If you pay close attention, this is a corded tool, and sometimes the cord gets in my way. So if you don't have a Dremel tool yet, I highly recommend you choose the cordless version. You could even get away with ordering a cheap Chinese version under the name Rotary Tool for less than 20 bucks. So apparently the distance between the original upper shock absorber shaft hole was slightly larger than the distance between the new ones I just had my machinist drilled out. So I am milling away about 0.5 millimeter of material on the ends of each aluminum spacer for a total of 1 millimeter of material removal. After modification of the spacers and upper shock absorber shaft rod, I was finally able to get the upper end of the shock absorber canister installed with a little help from a hammer. With the installation of quantity 2 6mm screws on the shaft rod, the installation of the suspension assembly is complete. Finally, minding the position of the motor cable, locate the motor shaft onto the swing arm and secure the wheel using 2 sets of 19mm hex nuts. Notice the stack-up consists of an anti-torque washer, a standard washer, a hex nut, and a cap nut. Torque should be around 40 foot-pounds. Here is the moment of truth, rolling the scooter off the lift table slowly, and look how beautiful the wheel bounces, just the right amount of shock absorption. Here is a closer look at the front suspension in action. Notice the displacement of the top shock absorber shaft rod position. It is a little squeaky, but I can fix that noise with some WD-40. The important thing is that the replacement was a success, and I can finally ride without knee pain. And finally, I want to send a very special message to the love of my life. I love you, Von Pink. Thanks for being my psychological support during this difficult job.